Did you know that over 1,000 Earths could fit inside Jupiter? This audiobook accompanies you on a serene journey through astonishing facts about the universe, from the secrets of the gas giant to curiosities about galaxies, stars, and deep space. 2 hours to relax, learn, and let yourself be carried away by the wonder of the cosmos as you gradually drift off to sleep. Since time immemorial, astronomers have set their sights on Jupiter, the king of the planets. Its size is so impressive that you could fit over 1,000 Earths like ours within its volume. But Jupiter's greatness is not limited to its size. Its composition and atmosphere are equally extraordinary. Did you know it is primarily composed of hydrogen and helium, the same elements that formed the Sun? This connection invites us to reflect on the formation of our solar system and the history of the celestial bodies that inhabit it. The exploration of Jupiter has been marked by pioneering missions, each unveiling unknown aspects of this giant. One of the most important milestones in this adventure was the Galileo mission, which not only provided us with stunning images of Jupiter, but also revealed the existence of its largest moons. What secrets do these satellites hold? The answer to this question could change our understanding of life elsewhere in the universe. When talking about Jupiter's moons, we encounter 4 main protagonists: Io, Europa, Ganymede, and Callisto. Each of these moons has unique features that make them worthy of study. Imagine a world where volcanoes constantly erupt, like on Io, while Europa could contain a hidden ocean beneath a thick layer of ice. Could this ocean be a refuge for life forms? This is one of the questions that motivate us to continue exploring. The Juno mission has been another crucial stage in the exploration of Jupiter. Launched in 2011, Juno has approached the planet to study its atmosphere and better understand its internal structure. What will its data tell us about the formation of Jupiter? The answers could shed light on how other planets formed and ultimately on the possibility of life on them. The Great Red Spot is another of Jupiter's most emblematic phenomena. This gigantic anticyclone has been in constant motion for centuries. How is it possible for a storm of such magnitude to persist for so long? The atmospheric dynamics that occur on Jupiter are complex, and we still have many questions to answer. Known for its intense storms, Jupiter is a natural laboratory where extreme weather phenomena can be observed. The storms on Jupiter are much more powerful than any hurricane on Earth. What forces in Jupiter's atmosphere give rise to these intense events? Understanding this is not only fascinating, but it could also help us better understand our own climate. An event that left an indelible mark on the history of astronomy was the impact of the Shoemaker-Levy 9 comet in 1994. This event not only showed us the destructive power of celestial bodies, but also allowed us to study Jupiter's atmosphere in reaction to an impact. What lessons did we learn from this event that can help us protect our planet? As we delve deeper into the exploration of the moons, Europa stands out for its potential to harbour life. Imagine an underground ocean, which could be a breeding ground for microorganisms. What future missions are planned to investigate this intriguing icy world? The search for life on Europa is one of the most exciting objectives of space exploration. Ganymede, the largest moon in the solar system, also has its own fascinating story. With a surprising magnetic field, this satellite could offer clues about the formation of other celestial bodies. How was this field formed, And what does it mean for the possibility of life on its surface? The answers to these questions are essential for understanding the environment in which life forms could exist. Callisto, on the other hand, is an ancient enigma. Its surface is marked by craters that tell the story of past collisions. What secrets does this world hold that has remained relatively unchanged over the eons? The exploration of Callisto could reveal more about the history of the solar system. The formation of Jupiter is another topic of great interest. Theories about how this gas giant formed help us understand not only Jupiter, but other planets in our solar system and beyond. What role did Jupiter play in shaping the solar system as we know it today? With all that we have learned, it is also crucial to analyze Jupiter's chemistry. Its composition provides clues about planetary formation and the evolution of solar systems. What does its atmosphere tell us about the processes that led to life on Earth? Jupiter's powerful magnetic field is another of its great mysteries. This field affects its environment and creates stunning auroras at its poles. What do these auroras tell us about the interaction between Jupiter and the Sun? The answer to this question could have implications for our understanding of the solar system. Finally, we cannot overlook the connection between Jupiter and the Sun. Jupiter's gravitational influence has a significant impact on the dynamics of the solar system. How does its gravity affect other planets and celestial bodies? This is an aspect that invites us to reflect on the interconnection of all the components of our solar system. The exploration of Jupiter and its moons is a journey that leads us to question and discover more about the universe we inhabit. As we continue to search for answers, each mission, each discovery, brings us a little closer to understanding if we are alone in the cosmos. What does the future hold for us in this search for life beyond our planet? The adventure is just beginning. Jupiter, the gas giant, stands as the king of our solar system. But what makes it so special? This colossus is not only the largest planet, but it also possesses fascinating characteristics that set it apart from all the others. Did you know that if we were to combine all the planets in the solar system, Jupiter would still be more massive than them combined? In a sense, it's as if Jupiter is the big bodyguard protecting the smaller planets from potential cosmic catastrophes. Its size is dazzling. Jupiter has a diameter of around 89,000 kilometers. To put that into perspective, you could fit over 1,000 Earths inside Jupiter. But it's not just about dimensions. This planet is a gas giant, which means it doesn't have a solid surface like ours. Instead, it's primarily composed of hydrogen and helium, with layers of clouds forming a visually fascinating spectacle. Can you imagine being in a place where there's no solid ground, but only an immense atmosphere that seems to stretch into eternity? One of the most intriguing features of Jupiter is its atmosphere. It's filled with storms, winds, and weather phenomena that leave anyone in awe. The famous Great Red Spot, for example, is a gigantic storm that has been active for over 300 years. Can you imagine a storm that has lasted so long it could have been seen by entire generations? It's like a battle between forces of nature that never stops. At the top of its atmosphere, we find vibrant coloured clouds in shades of white, orange, and brown that intertwine in an almost artistic manner. These clouds are formed by different chemical compounds that react with each other, creating patterns that seem to be taken from an abstract painting. Who would have thought that such a distant planet could also be a cosmic canvas? The temperature on Jupiter is extremely cold, reaching less than 200 degrees below zero in its outer layers. But as we descend towards its interior, things change dramatically. The pressure and heat increase, creating an environment where conditions are completely alien to us. Imagining a place where gravity is so intense that gases behave completely differently is something that challenges our understanding. The gravitational force of Jupiter is another fascinating aspect. This planet has a gravity that is more than 2.5 times greater than that of Earth. This means that if you weighed yourself on Jupiter, you would weigh much more than you do here. Can you imagine what it would be like to walk in a world where every step requires monumental effort? It's like trying to jump in a pool of jelly, where every movement is a challenge. In addition to its atmosphere, Jupiter is known for its powerful magnetic field. This field is so strong that it creates an environment of intense radiation around the planet, capable of trapping charged particles in its orbit. Did you know that this magnetic field is more than 20 times stronger than Earth's? It's as if Jupiter is surrounded by a protective shield that defends it from many cosmic threats. The exploration of Jupiter has shown us that this planet is not just a sphere of gas. Through space missions, we have learned about its complex atmospheric dynamics and its chemical composition. But what about its history? Jupiter, like other planets, formed billions of years ago from the same cloud of gas and dust that gave birth to the Sun and other celestial bodies. In this sense, it is a vestige of the early days of our solar system. Jupiter also acts as a huge magnet for asteroids and comets, thanks to its strong gravity. This means that its presence can help protect the inner planets, like Earth, from potentially devastating impacts. Imagine Jupiter as a great guardian constantly watching the path of cosmic dangers that could threaten our. The exploration of Jupiter has not only taught us about its own nature, but it has also given us clues about the formation of other planetary systems in the universe. By studying how Jupiter behaves, scientists can better understand how planets form and evolve in other parts of the galaxy. So, by observing this gas giant, we are looking not only into our past, but also into the future of space exploration. The allure of Jupiter is undeniable. Its beauty, its immensity, and its mysteries have fascinated astronomers and scientists for centuries. Every discovery about this planet brings us one step closer to understanding not only Jupiter, but also our place in the vast cosmos. The quest for answers about Jupiter is, in itself, a quest for our own origin and destiny. In summary, Jupiter is not just a giant planet. It's a world full of surprises, challenges, and wonders. From its vibrant atmosphere to its powerful gravity, every aspect of Jupiter tells a story that invites us to explore and learn more. So, as we continue to look up to the sky for answers, let's remember that Jupiter will always be there, like a beacon in the darkness of space, waiting to be discovered. Galileo Galilei, a name that resonates through the centuries, was a pioneer in astronomy who opened a window to the cosmos. But what exactly did he do, and why is he so important in the history of Jupiter's exploration? His mission, which bears his name, was a milestone in our understanding of the gas giant and its mysterious moons. This journey not only led us to know more about Jupiter, but it also ignited the spark of wonder about life on other worlds. The Galileo mission was launched in 1995 and ventured into the solar system for 6 long years before reaching its destination. In comparison, it's like waiting for a friend to arrive at your house on foot from a distant city. But this friend was travelling through space. Once it finally arrived at Jupiter in 1996, it began to send valuable information that would change our understanding of the planet. What secrets did it reveal? One of the main contributions of the Galileo mission was the observation of Jupiter's moons. Before its arrival, we only knew a handful of moons, but Galileo showed us that Jupiter had more than 20 moons in its orbit. Imagine a great king surrounded by his loyal subjects. That's how you can picture Jupiter, with its moons revolving around it. The most fascinating of all was Io, which turned out to be the most volcanic body in the solar system. Volcanoes in space. Isn't it amazing to think that there are mountains of lava and eruptions in such a distant place? But it didn't stop there. Galileo also discovered Europa, an ice-covered moon that could harbour an underground ocean. Could there be life beneath its icy surface? This question has become one of the most intriguing in the search for extraterrestrial life. Its exploration opened a new chapter in astrobiology, where the possibility of life becomes more accessible to humans. Ganymede, another fascinating moon, was revealed by Galileo as the largest satellite in the solar system. Think of it as a small planet with its own magnetic field, something nobody expected to find. What else could there be in the universe that we have not yet discovered? And then there's Callisto, the furthest moon from Jupiter's large moons. Its surface is so full of craters that it looks like an old vinyl record. Each of these craters tells a story of its own past, a tale of impacts and collisions that leads us to wonder how many more mysteries the solar system hides. But how did Galileo communicate with us? Through a series of images and data sent to Earth, its spacecraft became our eyes in space. It was like receiving letters from an explorer in an unknown place, each revealing a bit more of Jupiter's fascinating and unknown environment. The mission was not only a technological achievement, but also a reminder of human curiosity. For 7 years, Galileo orbited Jupiter, sending information that allowed us to study its atmosphere, its moons, and the magnetic field that surrounds it. What did these observations teach us? They showed us that Jupiter is not just a giant planet, but a world full of activity and complexity. The winds in its atmosphere are so strong that they can exceed hundreds of kilometers per hour, creating patterns that resemble moving works of art. Apart from that, the Galileo mission also faced challenges. The spacecraft suffered a malfunction that compromised the quality of the data, but the perseverance of scientists and human ingenuity allowed the mission to continue. This teaches us that, although we sometimes encounter obstacles, curiosity and the desire to learn can lead us to discover amazing things. The culmination of the Galileo mission was the immersion of the probe into Jupiter's atmosphere in the year 2003. This was a deliberate act to obtain final data, like sending a last goodbye to a planet that had shared so many secrets. Just as the explorers of old ventured into the unknown, Galileo said goodbye in a heroic way, leaving a lasting legacy. The mission not only illuminated the path for future explorations, but also gave us a glimpse of what might be beyond our planet. Jupiter and its moons are at the center of the conversation about the possibility of life on other worlds. Looking to the future, missions focusing on Europa and Ganymede promise to unveil even more mysteries. In the end, the Galileo mission reminds us that every discovery brings with it more questions. Curiosity is a spark that never goes out, and Jupiter, with its majesty and complexity, is an eternal reminder that there is still much to explore in the vast universe. Each moon, each storm, each finding brings us one step closer to understanding not only our place in the cosmos, but also the possibility that we are not alone. Jupiter is not only a gas giant in space, but also the home of a fascinating system of moons that pique the curiosity of scientists and astronomy enthusiasts alike. Did you know that Jupiter has over 70 known moons? But today, we will focus on 4 that are truly impressive: Io, Europa, Ganymede, and Callisto. Each one has its own story and unique features that deserve to be explored. Let's start with Io, the moon closest to Jupiter. This small world is a place of extremes. Can you imagine a place where volcanoes are constantly erupting and the surface is covered in sulfur? Io is the most volcanically active body in the solar system. Its surface is a mosaic of vibrant colours and desolate landscapes, the result of intense geological activity. Jupiter's gravitational pull causes Io to constantly deform, generating the heat necessary to keep its volcanoes active. It's as if Io is in a constant struggle against the giant that surrounds it, and this battle results in explosive beauty. Let's move on to Europa, another moon that arouses great interest. Imagine an icy world that hides beneath its surface an ocean of liquid water. Europa is this enigma. The scientific community believes that beneath its ice crust, there is an ocean that could harbour the necessary conditions for life. This ocean, in combination with the energy that comes from gravitational interactions with Jupiter, could create a conducive environment for forms of life. The question many ask is, could there be life on Europa? Future missions are designed to unravel this mystery, exploring further what is hidden beneath its frozen surface. Ganymede, the largest moon in the solar system, is another fascinating object of study. It is the only known satellite to have its own magnetic field. This field is a rare phenomenon in the realm of moons and raises intriguing questions about its internal composition and history. Ganymede is also an icy world, but unlike Europa, it has a mix of old and new features on its surface. Some scientists believe that its magnetic field could be indicative of an underground ocean similar to Europa's, making it an interesting candidate in the search for life. Then there is Callisto, an ancient enigma. Its surface is dotted with craters, suggesting it has been exposed to impacts for billions of years. Unlike Io and Europa, Callisto shows no signs of recent geological activity, making it a silent witness to the history of the solar system. Observing Callisto is like looking at a page from a history book, where each crater tells a story about the violent past of space. What secrets does Callisto hold on its ancient surface? The exploration of this moon could reveal more about the formation and evolution of celestial bodies in our solar system. Each of these moons presents a unique puzzle, and their study not only helps us better understand Jupiter's system, but also the dynamics of celestial bodies in general. What will the data collected by future missions tell us about the possibility of life on these worlds? The exploration of Io, Europa, Ganymede and Callisto is not just a journey into the unknown, but also a search for answers about our own place in the universe. As scientists continue to investigate these moons, more questions arise. How were they formed? What processes have shaped their evolution? Io, with its volcanic activity, could be a natural laboratory for studying plate tectonics, while Europa and Ganymede could offer clues about the chemistry necessary for life. And Callisto, with its ancient history, can help us understand how celestial bodies have changed over the eons. It's fascinating to think about how each moon of Jupiter could be a world in itself, full of stories waiting to be discovered. Future missions like the Europa Clipper mission are designed to further investigate Europa's composition and its possibilities of harbouring life. So, as we observe Jupiter and its moons from a distance, we wonder, what will the future reveal about these icy and volcanic worlds? Jupiter's moon system reminds us that there is still much to explore and discover in our own cosmic neighbourhood. Each moon is a reminder that the universe is vast and full of surprises, and that our quest for knowledge has only just begun. Human curiosity drives us to look beyond, to wonder what other secrets might be hidden in the farthest corners of space. So the next time you look up at the sky and see a bright point, remember that you could be looking at a world full of wonders, a world that could answer the deepest questions about life and our place in the cosmos. The exploration of Jupiter and its moons is a journey that is just beginning, and the future promises to be as exciting as the present. If you're enjoying this journey through the universe and want to keep exploring more cosmic mysteries, don't forget to subscribe to the channel and give the video a like. Thank you for being part of this Star Odyssey. The Juno mission is one of the most fascinating adventures in space, a journey that takes us to the heart of the gas giant Jupiter. But what makes this mission so special? Juno was not only sent to orbit and study Jupiter, but it also has the mission to unravel the secrets of its formation and evolution. Just like a detective in search of clues, Juno is equipped with tools to analyze Jupiter's atmosphere, gravitational field, and magnetic field, seeking answers about how our solar system was formed. Imagine a spacecraft that looks more like a communication satellite than an exploration probe. Juno is designed to withstand extreme conditions, such as the intense radiation and extreme temperatures found in the vicinity of Jupiter. This probe is like a fearless explorer who dares to enter inhospitable territory, where danger lurks at every moment. But how does it manage to survive in such a hostile place? The answer lies in its heat shield, which acts as a sunscreen, keeping its delicate instruments safe. One of the most intriguing questions Juno is trying to answer is, what is the composition of Jupiter's atmosphere? The probe is equipped with a spectrometer that allows it to analyze the chemical traces of the clouds. This is similar to how a chef can identify the ingredients of a dish just by smell. Through this analysis, Juno tries to discover whether Jupiter has a solid core and how elements are distributed in its atmosphere. The mission also focuses on understanding Jupiter's gravitational field. Have you ever wondered how planets interact with each other? Jupiter, being the giant of the solar system, has such a powerful gravitational field that it affects other celestial bodies. Juno measures these variations in the gravitational field, which could provide clues about Jupiter's internal structure. It's as if Juno were taking an ultrasound of the planet, revealing what lies beneath its surface. In addition, the Juno mission is designed to study Jupiter's magnetic field, which is the strongest of all the planets in the solar system. Why is this so important? This magnetic field not only protects Jupiter from solar radiation, but it also creates stunning auroras at its poles. Juno can measure these phenomena, offering scientists a view of how the solar wind and the magnetic field interact, similar to how sea waves crash against a cliff. One of the most exciting aspects of Juno is its orbit. The probe approaches Jupiter in a series of elliptical orbits, allowing it to make detailed observations without getting trapped in the intense radiation surrounding the planet. This flight pattern is like a cosmic dance, where Juno approaches, takes pictures and moves away, making sure not to get caught by the whirlwind of energy that surrounds the gas giant. Every time Juno approaches Jupiter, scientists eagerly await the data the probe sends back to Earth. Each new discovery is like opening an unexpected gift. The collected data not only help understand Jupiter, but they also shed light on the formation of other planets and the history of the solar system as a whole. Could Jupiter have been a key piece in the creation of Earth? The Juno mission also raises questions about the evolution of Jupiter's atmosphere. Over time, has its composition changed? Has there been any volcanic eruption that has affected its climate? Juno is there to observe and record these changes, like a chronicler documenting the history of an old king. A fascinating aspect is how Juno has revealed a more dynamic Jupiter than we imagined. The storms in its atmosphere are more complex and diverse than previously thought, leading us to wonder, how do these storms influence the dynamics of the planet? Are they simple atmospheric phenomena, or do they have a deeper impact on Jupiter's internal structure? The images that Juno has captured are of indescribable beauty. Jupiter's clouds, with their vibrant tones and unique patterns, are like a constantly changing work of art. Each photo is a reminder of the majesty of the universe and how little we still know. What secrets are hidden behind those colours and shapes? The Juno mission is not just an exploration of Jupiter. It is a journey of discovery that helps us understand our place in the cosmos. By studying Jupiter and its features, we are learning about the processes that have shaped our solar system and, potentially, other star systems in the universe. What else will Juno reveal to us in the future? In summary, Juno is more than a simple space probe. It is a window to Jupiter's past, present, and future. With each data transmission, we get a little closer to unraveling the mysteries of this gas giant, challenging our understanding and opening new possibilities. The quest for knowledge is endless, and Juno is a testament to the human desire to explore and understand the universe we live in. What other secrets does the cosmos hold for us? Only time and curiosity will tell. Jupiter's Great Red Spot is one of those phenomena that, upon hearing about it evokes a mix of awe and curiosity. What exactly is this enormous spot on the gas giant, and why has it captured the attention of scientists and enthusiasts alike? To put it into perspective, the Great Red Spot is a gigantic hurricane that has been active for over 300 years. Imagine a tornado on Earth, but multiplied by several thousand times in size and duration. This gigantic vortex has a diameter that could accommodate 3 Earth-sized planets. It's hard not to feel small when thinking about it. The first question that arises is, how does a storm of such magnitude form on a planet like Jupiter? The answer lies in the planet's atmosphere, which is primarily composed of hydrogen and helium, but also contains traces of other gases. This mixture creates ideal conditions for the formation of huge storm systems. Unlike Earth, where storms are fueled by the energy of the Sun, on Jupiter, the atmospheric dynamics are driven by the planet's internal heat. This heat originates from its core, causing gas currents to move at impressive speeds, generating vortices that can grow and sustain themselves for centuries. Why is the Great Red Spot red? This striking colour is due to the presence of chemical compounds in the atmosphere, which react with sunlight. As the storm moves and evolves, its colour can change, making it even more intriguing. Sometimes it may appear darker, while at other times it may glow with a more intense hue. This phenomenon is a reminder that, although Jupiter is cold and distant, its atmosphere is full of activity and dynamism. What happens inside this colossal storm? The Great Red Spot is a place of chaos and beauty. The winds within it can reach speeds of up to 200 kilometers per hour. To put it into context, that's faster than most of the strongest storms we experience on Earth. Moreover, its size and duration have led scientists to speculate that it could be a remnant from a time when Jupiter's atmosphere was even more active. Over the years, telescopes and space missions have provided a wealth of information about the Great Red Spot, but there are still unanswered questions. Why does it still exist? Could it disappear in the future? The history of this storm poses a fascinating enigma. Some scientists have suggested that the Great Red Spot might be decreasing in size. If this is true, it could be an indication of changes in Jupiter's atmospheric dynamics, which could have implications for our understanding of the planet. The Great Red Spot is just one of many storms that form on Jupiter. In fact, the planet is filled with smaller storm systems, each with its own unique characteristics. In this sense, Jupiter resembles an artist constantly painting his canvas, creating and destroying patterns always in motion. This constant atmospheric activity is not only fascinating in itself, but also helps us better understand how other planets in our solar system and beyond work. Observing the Great Red Spot also provides us with a unique opportunity to study the physics of storms. Through comparisons with storms on Earth, scientists can discover similarities and differences that could reveal how storms develop on other worlds. Moreover, by examining the composition and dynamics of the Great Red Spot, researchers can gain clues about Jupiter's atmospheric history and how it has evolved over time. The Great Red Spot, in its majesty and mystery, is not only a phenomenon that shines in Jupiter's sky, but also acts as a mirror reflecting our own curiosity about the cosmos. The search for answers about this storm invites us to explore beyond our own planet and to wonder about the nature of the universe. What other secrets await in the far reaches of our solar system? In the end, the Great Red Spot is a reminder that, although we are small compared to the vastness of the cosmos, our curiosity and desire to understand lead us to make amazing discoveries. Each new finding about Jupiter and its storms brings us a little closer to unraveling the mysteries of the universe. What else will the Great Red Spot teach us in the future? The exploration continues, and with it, our capacity for awe is constantly renewed. Storms on Jupiter are true spectacles of nature, phenomena that show us the strength and beauty of the universe. But what makes them so different from the storms we know on Earth? On this gas giant, storms can last for years, even centuries, and their size is simply astonishing. Imagine a hurricane larger than Earth, with winds exceeding 300 kilometers per hour. That's what Jovian storms are like. One of the most fascinating aspects of Jupiter is how its atmosphere is composed of different layers, each with unique characteristics. These layers are in constant motion, creating a dynamic and chaotic environment. In comparison, our atmosphere is much more stable. But why does this happen on Jupiter? The answer lies in its composition and the enormous amount of energy produced by its interior. The energy inside Jupiter is generated by the compression of gases and the release of heat. As you descend into the planet's atmosphere, temperatures rise dramatically. This combination of heat and moving gases creates air currents that can unleash storms of epic proportions. Imagine a giant blowing forcefully, creating winds that spin and whirl in a cosmic dance. That is the essence of Jupiter's storms. At the center of this phenomenon is a curious contradiction. While on Earth winds tend to be gentler and storms shorter, on Jupiter, the enormous gravity and lack of solid surface allow storms to develop without limits. This means they can grow and evolve for much longer. But how long can they really last? Some storms, like the Great Red Spot, have been present for over 300 years, like an ancient guardian of the planet. The Great Red Spot is just one of the many storms you can find on Jupiter. However, its size and color make it one of the most iconic. This storm is so large it could swallow the entire Earth. But what makes it so special? It is said that its reddish color is due to chemical processes in the atmosphere, where sulfur and phosphorus compounds react with sunlight. It's as if Jupiter were painting its own canvas in the cosmos. In Jupiter, storms are not only large, but also extremely varied. You can find ribbon-shaped storms that seem to run through the atmosphere like snakes. There are others that resemble giant whirlpools, creating patterns that could remind you of the works of an abstract artist. In this sense, Jupiter is like a constantly changing canvas, where the atmosphere becomes a natural art gallery. The question that arises then is, how are these storms formed? The answer lies in the differences in temperature and pressure in the atmosphere. When warm air rises and meets cold air, convection currents are generated that give rise to clouds and eventually to storms. On Jupiter, these currents are much more intense due to its large size and the enormous amount of heat it emits. So, in a way, Jupiter is always in a kind of storm of activity. An intriguing aspect is how Jupiter's storms affect its environment. Its huge magnetic field and intense radiation can interact with solar winds and create stunning auroras at its poles. These auroras are not just a visual spectacle, but also offer us clues about the planet's atmospheric dynamics. Each flash of light is like a small reminder of the vibrant life taking place in this immense atmosphere. As space probes have explored Jupiter, they have revealed even more about the complexity of its storms. The Juno mission, for example, has provided fascinating data about the structure and patterns of the storms. Thanks to this information, scientists can better understand not only Jupiter, but also other planets in our solar system and beyond. In fact, studying these storms could help us understand the meteorology of exoplanets in other star systems. And what about life in these storms? Although it seems unlikely that anything could survive in such a hostile environment, research on the chemistry of Jupiter's clouds reveals compounds that could be interesting for astrobiology. In this sense, each storm can be seen as a natural laboratory, where chemical reactions take place that could offer clues about life on other worlds. Finally, let's reflect on the importance of studying Jupiter's storms. Through their research, we not only expand our knowledge about the largest planet in the solar system, but we also learn lessons about atmospheric dynamics that can be applied to our own world. In a broader sense, understanding these storms connects us with the cosmos, reminding us that although Jupiter is a distant giant, its mysteries are part of our quest to understand the universe in its entirety. Jupiter's storms, with their immense beauty and power, show us that the universe is a place full of surprises, and in each flash of light and each twist of wind there is a story waiting to be told. What is the story behind the impact of the Shoemaker-Levy 9 comet on Jupiter? This event, which took place in 1994, was not only a stunning spectacle in the sky, but it also opened a unique window to understand the dynamics of the solar system. Imagine a series of massive explosions like cosmic fireworks that transformed the appearance of the gas giant and provided us with valuable information about its atmosphere. The Shoemaker-Levy 9 comet was not just any comet. It had been captured by Jupiter's gravity and had split into more than 23 fragments, each as large as our fountain. When these fragments fell into the Jovian atmosphere, they did so at an astonishing speed, generating explosions that released energy equivalent to millions of megatons of TNT. To put it in perspective, this is as if each comet fragment was a nuclear bomb. Astronomers were not only observing the impacts, they were in a kind of race against time. With each collision, huge dark spots were generated in Jupiter's atmosphere, visible even from Earth. These spots were silent witnesses to the power of nature. But what did these impacts teach us about Jupiter and its environment? Scientists realized that despite being a gas giant, Jupiter's atmosphere is a very active place. The Shoemaker-Levy 9 explosions revealed that the atmosphere is composed of dynamic layers that interact in complex ways. Each explosion caused shock waves that propagated through the atmosphere, providing information about its composition and structure. In addition, the impacts helped researchers better understand Jupiter's gravity. Its immense gravitational field not only captures comets, but also influences the trajectory of asteroids and other celestial bodies. This event highlighted how Jupiter acts as a guardian of the solar system, protecting Earth from potential threats by attracting objects to its own atmosphere. Another fascinating aspect is how Shoemaker-Levy 9 demonstrated the importance of space exploration. Before this event, many thought that impacts on gas planets were uncommon. However, this event revealed that, in fact, impacts are an integral part of the behaviour of these planets. The study of these phenomena is not only crucial for Jupiter, but also for understanding the history of other celestial bodies. How did scientists feel observing such a spectacular event? Excitement and anticipation were in the air. For years they had been preparing for this moment, and when it finally happened, observations were broadcast in real time through telescopes around the world. It was a celebration of science, an opportunity for astronomers to share their passion and knowledge with the public. As the comet fragments impacted Jupiter, the planet lit up with flashes of light, creating a kind of cosmic fireworks display. This display was not only visually stunning, but also allowed scientists to study the chemical reactions occurring in the Jovian atmosphere. The explosions generated extreme temperatures that triggered the formation of new compounds, revealing secrets about the planet's chemistry. The results of these observations were not long in coming. It was discovered that Jupiter's atmosphere is a natural laboratory where complex chemical reactions occur. This information is vital not only for understanding Jupiter, but also for investigating other planets and their possible conditions for harboring life. In terms of cultural impact, Shoemaker-Levy 9 became a benchmark in astronomy. Documentaries, lectures, and studies were conducted that discussed not only the event itself, but also its implications for space exploration. This event also boosted international collaboration between scientists and space agencies, demonstrating that the pursuit of knowledge has no borders. The legacy of Shoemaker-Levy 9 continues today. Future missions to Jupiter, such as the Juno mission, benefit from the data collected during this event. Scientists now have a better understanding of how impact can influence the atmosphere and how planets interact with each other. The story of the Shoemaker-Levy 9 comet is a reminder that the universe is full of surprises, and that often the most drastic events can teach us the most valuable lessons. The next time you look at the sky, think about those comet fragments that crashed into the gas giant. Each impact was an opportunity to learn more about the world we live in and the vast cosmos that surrounds us. So, as we continue to explore Jupiter and its moons, let's remember that each discovery is like a bright flash in the dark vastness of space, illuminating our path towards knowledge and understanding of the universe. The search for answers continues, and each question that arises can lead to new wonders and discoveries in the future. Europe, one of Jupiter's most fascinating moons, is an icy world that hides secrets beneath its surface. What lies beneath that ice crust? The answer to this question could change our understanding of life in the universe. Imagine a vast, immense, and hidden ocean stretching beneath an ice layer that, although cold and distant, could harbour the necessary conditions for life. This ocean, estimated to be deeper than all of Earth's oceans combined, is the focus of scientists around the world. Evidence for the existence of this ocean is not mere conjecture. exploration missions have provided data suggesting the presence of liquid water, an essential ingredient for life as we know it. But how was this conclusion reached? Through detailed observations of Europa's surface, a pattern of fractures and movements indicative of an active internal dynamic has been identified. These features are similar to those we see in the tectonic plates of our own planet. Europa is not only of interest for its oceans, its icy surface is also full of mystery. Why is it covered in such smooth ice? Some scientists suggest that this ice could be in constant motion, like a gigantic puzzle that is constantly reconfiguring. Imagine a scenario where these ice pieces separate and slide, allowing the water below to gush to the surface. This phenomenon could be the key to understanding not only Europa's geology, but also its potential to harbour life. But here arises an intriguing question. If there is life in that subterranean ocean, what would it be like? Although life on Europa could be very different from what we know, scientists base themselves on the extreme life that exists on Earth to imagine possible forms of life on other worlds. From microorganisms living in the depths of our oceans to organisms that thrive in extreme environments such as hydrothermal vents, nature has shown that life can adapt to very adverse conditions. Furthermore, the search for life on Europa is not limited to theories. Missions are being planned specifically designed to investigate this moon. Projects like NASA's Europa Clipper aim to send probes to explore Europa's surface and subsurface for signs of life. These missions are not only looking for water, but also chemical elements that can sustain life, such as carbon, oxygen, and hydrogen. What exciting discoveries await us in the future? The chemistry found in Europa's ocean is another piece of the puzzle. Could there be chemical reactions that feed forms of life? On Earth, life has adapted to very diverse environments, from the burning fire of volcanoes to the extreme cold of glaciers. The possibility of life existing on Europa leads us to rethink our ideas about where and how life can exist in the cosmos. A fascinating aspect of Europa is its potential to be a place where life could have started instead of having arrived from another world. If Europa's ocean is truly rich in nutrients and energy, it could be a conducive environment for life, even in its most primitive forms. Imagine a completely new ecosystem, developed in isolation, far from the influence of Earth. The exploration of Europa is a monumental challenge. The distance and extreme conditions make reaching this moon a technological feat. But what would stop us? Human curiosity and the desire to discover the unknown have driven many of our greatest adventures. The possibility of finding life on Europa could be one of the greatest milestones in space exploration. As these missions are planned, science continues to advance in understanding Europa and its ocean. Research on Jupiter's magnetic field and its interaction with Europa also offers clues about what we might find. This magnetic field can affect the chemistry of the subterranean ocean, creating unique environments that could be essential for life. Each new discovery about Europa raises more questions. What type of life could adapt to its environment? How would it survive in a place where sunlight is almost non-existent? These questions are not only scientific, but also invite us to reflect on the nature of life itself and its ability to flourish in extreme conditions. The search for life on Europa is a reminder of how little we really know about the universe. As our probes delve into the unknown, each new piece of data becomes a valuable piece of a cosmic puzzle. The possibilities are endless, and the exploration of Europa is just one chapter in the long history of our quest to understand our place in the universe. On this journey into the unknown, it is crucial to keep an open mind. Europa could be a place where life is waiting to be discovered, or it could be a reminder of what we still do not know. But one thing is certain: the exploration of Europa is not just a search for answers, but a journey towards understanding what it means to be human in a vast and mysterious cosmos. Ganymede, Jupiter's largest moon, is a true enigma of the solar system. What makes it so special that scientists consider it a magnetic world? To understand this, we must first look at its size. Imagine a place so large that it could house all the planets in the solar system, and there would still be room to spare. Ganymede is not only enormous, but it also has fascinating features that set it apart from any other known natural satellite. One of the most intriguing features of Ganymede is its magnetic field. Did you know it's the only moon in the solar system that has one? This magnetic field is like a protective bubble that envelops Ganymede and isolates it from the solar wind emanating from the sun. It's as if it had its own armor, protecting it from the charged particles traveling through space. This phenomenon is due to an iron core inside it that, like Earth's, generates a magnetic field. But what does this mean for the moon and its potential to harbor life? Ganymede is not only large and magnetic, but it also features a surface marked by a diverse landscape. Craters, broken terrains, and icy plains make up its surface. Can you imagine what it would be like to walk in a place where craters have witnessed asteroid impacts for millions of years? Each of these craters tells a story about Ganymede's past and the events that have shaped its surface. Compared to other moons like Io, which is volcanically active, Ganymede seems to have a quieter history, but that doesn't mean it's less interesting. The combination of its size, its magnetic field, and its unique surface raises intriguing questions about its interior. Could there be an ocean of liquid water beneath that ice layer covering it? Some scientists suggest that beneath the thick ice crust, there could exist a salty ocean that could provide the right conditions for life. This idea is not just a guess. In fact, space missions have collected data suggesting there is liquid water inside Ganymede. The features of Ganymede lead us to wonder, how was this complex world formed? Like other celestial bodies, Ganymede was formed from the same gas and dust cloud that created Jupiter and the rest of the solar system. But as it was forming, its composition and the gravitational forces around it influenced its development. What role did Jupiter and its other moons play in Ganymede's evolution? The study of Ganymede is not limited to its surface and magnetic field. It is also crucial in understanding the history of the solar system. Why? Because by studying moons like Ganymede, we can gain clues about the processes that shaped other planets and satellites. Each crater, each plane, and each fracture on its surface is a record of cosmic history that helps us understand how space has changed over the eons. As scientists continue to explore Ganymede, New questions arise about its environment. The interaction between its magnetic field and the solar wind is an exciting area of study. How does this affect its atmosphere, if it has one? Magnetic interactions can influence how the solar wind interacts with the ice on the surface, which in turn could affect any underground ocean. It's a delicate balance that researchers are eager to unravel. The data collected by past missions have shed light on Ganymede, but there is still much to discover. The next mission of the European Space Agency, called JUICE, Jupiter Icy Moons Explorer, will focus on studying Ganymede and its icy sisters. This mission aims to explore in detail the composition and dynamics of Ganymede, as well as any possible underground ocean. What secrets will this mission reveal about Jupiter's largest moon? The exploration of Ganymede also raises a fundamental question about the search for life on other worlds. Could this magnetic satellite harbour forms of life? The combination of liquid water, energy and chemical compounds could be the perfect breeding ground for life. The possibility that organisms exist in the depths of its underground ocean is a concept that fascinates us. Could we find life not only on Ganymede but on other icy bodies in the solar system? Ganymede represents more than just a satellite. It's a natural laboratory that gives us the opportunity to explore the conditions that could give rise to life. As we advance in the era of space exploration, each discovery brings us a little closer to answering that age-old question: are we alone in the universe? Research on Ganymede and other moons of Jupiter is a crucial step in this journey of discovery. In summary, Ganymede is a world full of surprises, with an intriguing magnetic field, a surface full of history, and the possibility of an ocean that could harbour life. The exploration of this moon not only teaches us about its own environment, but also offers us a window into the history of the solar system and the conditions that could make life possible elsewhere. Jupiter's largest moon is a reminder that the cosmos is full of mysteries waiting to be discovered. Callisto, that moon that seems like an ancient enigma, presents itself to us as a fascinating world full of surprises. What secrets does its crater-marked surface hold? As we explore this moon, we encounter a landscape that reminds us of Earth's moon, but with a unique story to tell. Callisto is not just another satellite. It is an open book on the history of the solar system, a silent witness to the impacts that have shaped not only its surface, but also that of other celestial bodies. Looking at Callisto, it's hard not to be intrigued by its appearance. Its surface is littered with craters, some of which are larger than any city on our planet. But what does this mean? Each crater is a mark, a memory of a moment when an object from space collided with this moon. In a sense, each crater is like a fingerprint that tells us the story of Callisto, revealing the number of impacts it has suffered over billions of years. Can you imagine how many stories those craters could tell if they could speak? But why are there so many craters on Callisto? This moon is special because, unlike other celestial bodies, it does not have a significant atmosphere to protect its surface. On Earth, the atmosphere acts as a shield, disintegrating many objects that try to enter. On Callisto, the absence of this shield means that any small meteoroid that approaches can collide directly, leaving its mark. Thus, Callisto becomes a true museum of impacts, where each scar tells a story of what has happened in the vast universe. Delving into the study of Callisto, we find that its interior is another mystery to solve. While some moons of Jupiter, like Europa, have oceans of water beneath their surface, Callisto appears to be drier. However, this does not mean that it is completely empty. Through observations made by space missions, it has been suggested that there could be a subterranean ocean, although it is not confirmed. What conditions could exist in the depth of Callisto? There could be life, or at least the necessary ingredients for life waiting to be discovered. It is fascinating to think that, although Callisto is one of the oldest bodies in the solar system, its history is still not fully revealed. But how was it formed? It is believed that Callisto was formed in the same disk of gas and dust that gave rise to Jupiter and its other moons. However, unlike Io and Europa, which are closer to the gas giant, Callisto is on the periphery of its influence. This distance has allowed its geology to remain relatively stable over time, preserving its primitive appearance. The surface of Callisto is also a place of contrasts. Despite being full of craters, there are regions that appear smoother, as if they had been smoothed by unknown processes. Some scientists suggest that these could be areas where ice has emerged to the surface, creating a landscape that seems to slowly change over time. Could it be that the geological activity on Callisto has not completely died down? The answer to this question could have important implications for the history of this moon and its potential to harbour life. The story of Callisto also intertwines with that of its sister moons. Compared to Io, which is a volcanic world, and Europa, which has an icy ocean, Callisto presents itself as a quieter place. However, that tranquility is deceptive. The gravitational interaction with Jupiter and other moons can generate tensions in its interior, which could lead to unexpected geological activities. What mysteries does its interior hide? Science still has much to discover. Imagine a future in which scientists can send a mission to Callisto. They could land on its surface and conduct experiments that help us unravel the secrets of its history. Perhaps they will find ice, or even evidence of an ocean. What impact would this have on our understanding of life in the universe? Each discovery on Callisto could bring us one step closer to answering the big question: are we alone in the cosmos? Jupiter's moons, each with its own personality, offer us a unique window into the diversity of the solar system. Through studies like those conducted on Callisto, we begin to understand that each celestial body has its own narrative, a story that deserves to be told. The exploration of Callisto not only helps us learn more about this moon, but also about the evolution of planets and moons in general. Every time we look at the sky and see Jupiter shining, let's remember that its moons, including Callisto, are part of a much larger story. Each crater, each layer of ice, each possible subterranean ocean are hints of a past filled with cosmic events. What other secrets are hidden in this ancient moon? Only time and science will tell. So the next time you think of Callisto, remember that it is not just another celestial body. It is a place full of mystery, a testament to the history of the universe, and a key piece in the puzzle of life. Who knows what discoveries the future will bring? The exploration of Callisto could just be the beginning of a new era in the search for answers about our existence in the vast cosmos. Can a frozen world hide an ocean? Europa, one of Jupiter's moons, has captured the imagination of scientists and dreamers alike. Its ice-covered surface conceals a secret that could change our understanding of life in the universe. Scientists believe that beneath this ice layer, there could be a vast ocean of liquid water. But what does this mean for the search for life? Could Europa be home to organisms that defy our current understanding of biology? The idea of liquid water on Europa is fascinating. On Earth, where there is water, there is also life. From rivers to oceans, water is the vital element that has allowed life to flourish. If Europa has an ocean beneath its surface, the possibilities are exciting. To imagine creatures swimming in those dark, cold waters is something worthy of a science fiction novel, but it could be more real than we think. Future missions are specifically designed to explore this intriguing moon. NASA's Europa Clipper mission, for example, aims to conduct a detailed analysis of Europa's surface and subsurface. But what data do they hope to obtain? The spacecraft will carry out a comprehensive study of the ice's chemical composition and will try to discover if there are signs of geological activity that could indicate the presence of liquid water. Will it be enough to answer our questions about life? The search for life on Europa also poses challenges. The intense radiation emitted by Jupiter represents a significant hurdle. Scientists must design instruments that can withstand this radiation and continue to function properly. It's like trying to keep a car running while driving through a sandstorm. What strategies are being implemented to overcome these obstacles? In addition to radiation, Europa's surface itself is a puzzle. With its fractures and lines that seem to tell the story of a moving world, every scratch could be a clue about what lies beneath. What secrets does this icy landscape hold? Every image and data collected by future missions will bring us a little closer to the answer. It's important to consider that Europa is not the only place in the solar system that could harbour life. However, its proximity to Jupiter and the conditions suggested by its underground ocean make it one of the main candidates. What other moons or planets could be equally fascinating? The exploration of Europa could be a crucial step on the path to identifying other habitable worlds. The longing to discover life elsewhere is not just a scientific matter, but also a reflection on our own existence. Are we alone in the universe? The search for life on Europa becomes a mirror reflecting our own questions about humanity. The possibility of finding life, even in simple forms, could have profound implications for our understanding of our place in the cosmos. Every new discovery about Europa and its potential ocean is a step forward in our exploration of the solar system. Science is advancing by leaps and bounds, and with each mission, a new chapter opens in our search for answers. What stories will the data collected by these space explorers tell us? Scientific curiosity is insatiable, and each answer generates even more questions. As we approach the realization of these missions, international collaboration becomes essential. Scientists from around the world are working together to unravel the mysteries of Europa. This collective effort reminds us that the search for life is not just a goal of one country or organization, but a longing shared by all humanity. How can the world unite in this common quest? As we advance in time and technology, our desire to explore becomes stronger. The missions to Europa are just the beginning. Every new technology developed to explore this frozen world could have applications in other areas of science and everyday life. What innovations will emerge from space exploration? Europa, with its hidden secrets and mysterious ocean, is a reminder that there is still much to discover in our own solar system. Human curiosity has been the engine of exploration, and Jupiter's icy moon is a destination that could rewrite our history. Looking towards the future, we must remember that every advance in science brings us a little closer to the truth. So, what does the future hold in the search for life on Europa? The answer to this question could change our understanding of the universe and our place in it. With each mission, each study and each discovery, we get closer to unveiling the mystery of whether we are not alone in the vast cosmos. Exploration is not just a physical journey, but a journey into ourselves, in search of answers that have been within humanity since time immemorial. The Munio is a fascinating place, where volcanic activity brings to life a landscape that seems straight out of a science fiction tale. What makes Io so special? What truly stands out about this moon is its incredible number of active volcanoes. Imagine a world where the ground shakes and the sky lights up with eruptions of lava and ash. This is not a movie, it's the reality of Io, home to the most active volcanoes in the solar system. When we think of volcanoes, we often imagine smoking mountains on Earth. But on Io, the situation is much more extreme. The surface of this moon is filled with calderas and volcanic plains, suggesting that the interior of Io is in constant motion. But why does this happen? The answer lies in Jupiter's gravity, which exerts such a powerful force that it's literally stretching and compressing Io. This phenomenon, known as tidal heating, is the culprit of the intense volcanic activity we see on the moon. With each eruption, Io releases vast amounts of sulfur dioxide and other gases, creating a thin atmosphere that is constantly changing. Can you imagine a place where the atmosphere can look and feel different within hours? That's exactly what happens on Io. The moon's surface is constantly renewing, covered by flows of lava and ash that emerge from its interior. This not only makes it a visually stunning place, but also gives us clues about the geological processes that might exist on other celestial bodies. Io's volcanic activity also has effects on its surroundings. The moon emits a large amount of particles that become part of Jupiter's magnetic environment. Did you know that these interactions create a kind of aurora on Io? Just like the northern lights we can see on Earth, Io also has its own light displays, although they are generated by a much more hostile environment. This connection between Io and Jupiter is a reminder of how interconnected celestial bodies are in our solar system. Io's geology becomes a real enigma for scientists. Every time a space mission observes this moon, new features are discovered. Just like an artist is always looking for new ways to express themselves, Io continues to surprise us with its diversity of volcanic landscapes. What else could it hide on its surface? Future missions could help us unravel more of its secrets, revealing a world that is still full of surprises. In addition to its impressive volcanic activity, Io also raises intriguing questions about the possibility of life. While the intense geological activity may seem hostile, some scientists wonder if, in the deepest places of Io's interior, There could be conditions that allow the existence of extremophile life forms. Could there be organisms that adapt to this extreme environment, similar to those we find in the depths of our oceans on Earth? The search for life on Io is a field of study that sparks the interest of many researchers. The relationship between Io and its mother, Jupiter, is not only one of gravity, but also of history. As Jupiter was forming, its huge gravity affected the moons around it, creating a dynamic system. This interplay of forces has shaped Io over billions of years. Every eruption, every change on its surface tells a story about the past of this world. Investigating these processes helps us understand not only Io, but also how other bodies in our solar system were formed. Human curiosity about Io is insatiable. As technology advances, space missions become more sophisticated. We can now send probes that get close to Io and collect valuable data. Imagine being able to see those erupting volcanoes up close, watching how the lava flows and cools in real time. Each new image and each new piece of data bring us closer to understanding this incredible world. The study of Io is not limited to its geology and volcanic activity. We can also learn about the history of the solar system through this moon. Its surface is marked by craters and lava flows, representing a record of events that have occurred over time. What will these records reveal about the history of our own planet and the solar system as a whole? Each discovery on Io can give us clues about the past of Earth and other celestial bodies. As we continue exploring Io, we also reflect on what it means to be part of such a vast and wonder-filled universe. The search for answers to questions like, are we alone in the universe? Or, what other worlds could harbour life? Becomes a journey that transcends the physical. The exploration of Io is just one part of a broader effort to understand our place in the cosmos. As we delve into the future, the moon Io remains an exciting and mysterious destination. Each new mission offers us the opportunity to learn more, not just about Io, but about the very nature of life and existence. Io's volcanic activity may seem violent, but it's also a reminder that the universe is full of creative and destructive forces that shape our worlds. The story of Io is ultimately a story of discovery. As we explore its surface and study its activity, each finding is a step further towards understanding the processes that govern our solar system. So, as we continue to look towards the stars, let's not forget Io, the volcanic moon that reminds us that the universe is a place full of surprises and mysteries to unravel. Jupiter, the gas giant of our solar system, is a fascinating puzzle that invites curiosity. But how was this colossus formed? To understand the history of Jupiter, we must first go back in time, to an era when the solar system was a chaotic place, full of dust and gas. Imagine a vast ocean of cosmic particles spinning and clustering into a huge whirlwind. At the centre of this whirlwind, gravity begins to do its work. The formation of Jupiter is similar to the creation of a snowball. As small particles of ice and gas come together, they grow in size, attracting more material around them. Over time, this snowball becomes a gigantic planet. But what sets it apart from other planets? The answer lies in its composition and size. Jupiter is so massive that it could house over 1,000 Earths within it. This colossal size gives it extraordinary gravity, capable of attracting and retaining a large amount of gas, mainly hydrogen and helium. But it's not all that simple. As Jupiter was forming, its core was heating up due to pressure. This internal heat is crucial to understanding the planet's evolution. Unlike other smaller planets which cool down over time, Jupiter still retains some of that primordial heat. What implications does this have? The answer is that as it cools, changes also occur in its atmosphere, creating fascinating weather dynamics. The story of Jupiter is also tied to the formation of the solar system. This gas giant appears as a protector of the inner planets, acting as a shield against asteroids and comets. Like a guardian, its strong gravity deflects many of these celestial bodies, preventing them from colliding with smaller planets like Earth. However, what would happen if Jupiter did not exist? It's possible that Earth would not have been the safe place we know today. Research on the formation of Jupiter is not just an academic exercise. It has real implications for our understanding of astrobiology. By studying how planets formed, we also explored the conditions that could allow life in other star systems. So, what does Jupiter tell us about the possibility of life beyond our home? Theories about the formation of Jupiter have evolved over time. Initially, scientists thought that planets formed similarly to how stars form. However, with the advancement of technology and observations, new ideas have been proposed, such as the disk instability hypothesis. This theory suggests that Jupiter formed quickly from a collapse in the gas and dust disk surrounding the young Sun. Can you imagine a planet forming in a matter of thousands of years instead of millions? The diversity of materials that come together to form Jupiter is another fascinating aspect. From heavy metals to light gases, the planet's composition is a reflection of the environment in which it was created. This raises an intriguing question. How did the proximity of the Sun influence the formation of Jupiter? The answer lies in the conditions of the early solar system, where the heat of the Sun influenced the distribution of materials. As we explore more about Jupiter, curiosity also arises about its future. How will this giant evolve over the next billions of years? As the Sun turns into a red giant, Jupiter's life will drastically change. However, its enormous mass will allow it to remain intact for much longer than smaller planets. All of this leads us to an important reflection. Jupiter is not just a distant planet, but a crucial component of our solar system. Each discovery about its formation and evolution helps us better understand our place in the universe. The story of Jupiter is, in essence, the story of creation itself. Finally, the search for answers about the formation of Jupiter does not stop here. With ongoing space missions and advanced technologies, scientists continue to unravel the mysteries of this gas giant. Exploring Jupiter not only teaches us about our solar system, but also invites us to imagine the possibility of life in other corners of the cosmos. So, as we continue looking up at the sky and wondering about the existence of life beyond Earth, let's remember that the story of Jupiter is a fundamental chapter in the book of space exploration. Human curiosity to understand our universe is infinite, and Jupiter, with its majesty and mystery, is one of the gateways to that vast and unexplored world. What makes a gas giant like Jupiter stand out among all the planets in our solar system? The answer lies in its complex chemistry, a fascinating mix that not only reveals how it was formed but also offers clues about the evolution of the solar system itself. Jupiter, like a large cosmic laboratory, invites us to explore its secrets, and one of those secrets is its intriguing chemistry. To start with, did you know that Jupiter is mainly composed of hydrogen and helium? These two elements make up most of its atmosphere, almost as if Jupiter were a giant gas-filled balloon. But beyond these basic components, there is a variety of other elements and compounds that shape its atmosphere. In smaller proportions, we find ammonia, methane, water vapor, and even some traces of more complex compounds. Each of them plays a crucial role in the dynamics of its atmosphere and in the formation of its most iconic features. Have you ever wondered why Jupiter's atmosphere is so turbulent? The answer lies in the energy it receives from the Sun and in its own rotation. Jupiter spins on its axis faster than any other planet, completing a rotation in just 10 hours. This rapid rotation, combined with its vast atmosphere, generates powerful winds that can reach speeds of up to 300 kilometers per hour. Imagine these gusts of wind like a huge cosmic fan, creating complex and dynamic weather patterns that are unique in the solar system. Jupiter's chemistry not only affects its atmosphere but also influences the formation of its spectacular bands and spots. The coloured bands you see on its surface are the result of the mixing of different gases and the way they react with each other. Chemical compounds interact with solar radiation and the planet's internal heat, creating a palette of colours that ranges from bright white to dark brown. This phenomenon is like a constantly moving canvas, where chemistry acts as the brush that shapes its beauty. A fascinating aspect of Jupiter is its ability to generate energy. Through a process called gravitational contraction, Jupiter not only stays warm, but also emits more energy than it receives from the Sun. This phenomenon is due to the pressure and temperature in its core, where hydrogen is converted into helium, releasing heat in the process. Thus, Jupiter becomes a kind of cosmic stove, radiating heat and light into space. But how does all this relate to the formation of the solar system? Jupiter's chemical composition is a mirror of the conditions that existed in the protoplanetary disk, from which all the planets were formed. Jupiter acted as a hunter of material in its youth, accumulating gas and dust around it. Its enormous gravity allowed it to attract and retain a large amount of elements, which in turn influenced the formation of other smaller planets. Thus, Jupiter becomes a key piece of the puzzle of our solar system. Jupiter's chemistry also offers us clues about the possibility of life elsewhere. By studying the composition of its atmosphere, scientists can look for ingredients that could be essential for life, such as water and other organic compounds. Could it be that, in some corner of its vast atmosphere, the secrets of life are hidden? The answers to this question could change our understanding of what it means to be alive in the universe. As we explore Jupiter's chemistry further, we encounter another surprising aspect: its magnetic field. This powerful field is the result of the movement of metallic hydrogen inside it. This hydrogen behaves like an electrical conductor, generating a magnetic field that is more than 20 times stronger than that of Earth. This field not only protects Jupiter from solar radiation, but also creates incredible auroras at its poles. Jupiter's auroras are like dancing lights in the sky, created by the interaction of the magnetic field with the solar wind. Jupiter's chemistry also plays a fundamental role in the formation of its moons. As Jupiter was forming, its enormous gravity may have influenced the composition of the moons that orbit around it. Each moon has unique chemical and geological features. For example, Europa, with its icy surface, could harbour a subsurface ocean containing liquid water, an essential ingredient for life. The chemistry of Jupiter and its moons invites us to investigate further, seeking answers to questions that have intrigued humanity for centuries. The continued exploration of Jupiter and its chemistry is vital to our understanding of the universe. Each mission, each discovery, brings us one step closer to unraveling the mysteries of this gas giant. Future missions like the one planned for Europa will seek to find out more about its atmosphere and its potential to harbour life. Jupiter's chemistry not only tells us about its past, but also offers us a glimpse into the future of space exploration. In conclusion, Jupiter's chemistry is a fascinating topic that teaches us about the formation of planets, the dynamics of their atmospheres, and the search for life beyond Earth. By exploring these topics, we are closer to understanding our place in the cosmos and Jupiter's role as a keeper of secrets in the vast universe. The exploration of Jupiter is not only a journey into the unknown, but also a journey into the heart of the chemistry that connects all living beings. What other secrets will this gas giant hold for us in the future? Only time will tell. What makes a planet truly awe-inspiring? For Jupiter, the gas giant of our solar system, the answer lies in its colossal magnetic field. But what does that really mean? In simple terms, the magnetic field is like an invisible shield that protects the planet and affects everything around it, from its moons to the space that surrounds it. Imagine Jupiter as a giant magnet. This magnet not only attracts objects but also generates a surprising phenomenon. Its own magnetic field is the strongest of all the planets in the solar system. In fact, it is so powerful that it extends into the surrounding space, creating an area where the solar wind and charged particles from space interact in fascinating ways. But how is this powerful magnetic field formed? The answer lies within Jupiter. To better understand, let's think of Jupiter as a gigantic power generator. At its core, it is believed to be an ocean of metallic hydrogen, an exotic state of matter where hydrogen behaves like a metal. This ocean, being stirred by Jupiter's rapid rotation, which takes only 10 hours to complete a turn on its axis, generates electric currents. These currents, in turn, create the magnetic field that envelops the planet. It's as if a giant engine is running all the time, producing energy and force. But what does this mean for Jupiter's moons? Imagine you're in an amusement park and a large magnet is affecting all the rides. That's how Jupiter's magnetic field influences its moons, especially Io, Europa, and Ganymede. These moons experience gravitational forces that can cause incredible phenomena, such as active volcanoes on Io or the possibility of oceans beneath Europa's surface. The interaction between Jupiter's magnetic field and the solar wind is also impressive. This wind is a stream of charged particles emanating from the Sun, and upon reaching Jupiter, it encounters its powerful magnetic field. What do you think happens? The answer is that powerful auroras are generated in the polar regions of the planet. These auroras are like bright neon lights dancing in the sky, a visual display of the clash between the solar wind and the magnetic field. Now, how does this phenomenon compare to what we see on Earth? On our planet, the aurora borealis is a natural spectacle that occurs when the solar wind interacts with our magnetic field. However, Jupiter's auroras are much more intense and spectacular due to its larger magnetic field and the abundance of charged particles. Imagine an aurora that is hundreds of times brighter than what we can see in the Earth's night sky. Jupiter's magnetic field is not only impressive for its size and strength, it also has a direct impact on the radiation surrounding the planet. The charged particles that get trapped in the field can create extremely dangerous radiation belts, similar to the Van Allen belts we have on Earth, but much more intense. This raises an intriguing question. How does this affect space missions that want to explore Jupiter and its moons further? Satellites orbiting Jupiter must be designed to withstand this intense radiation. It's like sending an explorer to a place full of dangers, where every step must be carefully planned. Missions must consider how to protect their instruments and ensure they can collect data without being destroyed. This leads us to reflect on engineering and human creativity in space exploration. In addition, Jupiter's magnetic field also plays a crucial role in the formation of its atmospheric features. The electric currents it generates not only affect the moons, but also influence the dynamics of the planet's atmosphere. This means that the magnetic field is intimately related to the storms, winds, and temperature fluctuations we observe in this gas giant. So, what does all this tell us about Jupiter as a system as a whole? The magnetic field is not just an isolated phenomenon. It is a fundamental part of Jupiter's story. It helps us understand how it was formed, how it interacts with its environment, and most importantly, how it can influence the search for life on its moons. Every discovery we make about Jupiter's magnetic field opens new doors to questions about the universe. What other planets have similar magnetic fields? How does this affect the possibilities of life elsewhere? As we continue to explore, the gas giant reminds us that there is still much to learn in our vast and mysterious cosmos. Finally, Jupiter's magnetic field is a reminder of the complexity and beauty of the universe. It challenges us to look beyond what we know and wonder what other secrets the planets and their moons hold. By exploring Jupiter, we are not only discovering a distant world, but also deepening our own understanding of the place we occupy in the cosmos. Jupiter's auroras are a breathtaking spectacle that defies the imagination. But what exactly are they? To understand this, we first need to remember how auroras form on Earth. On our planet, auroras occur when charged particles from the Sun collide with the Earth's atmosphere, creating dancing lights in the sky. Jupiter, being the gas giant of the solar system, has an even grander spectacle. Imagine a symphony of lights unfolding on a cosmic stage, where colours shine with an intensity that surpasses anything we could see from Earth. Auroras on Jupiter are generated in a similar way, but with a crucial difference: the planet's enormous magnetic field. This field is so powerful that it's over 20,000 times stronger than Earth's. So when particles from the solar wind, which are like tiny projectiles shot from the Sun, approach Jupiter, the planet's magnetic field acts like a huge magnet, capturing these particles and directing them towards the poles. Can you imagine the impact of that energy? It's as if Jupiter had its own defense system. But what happens when these particles collide with Jupiter's atmosphere? Huge amounts of energy are released, creating those bright auroras. The difference is that instead of being just green and pink like on Earth, Jupiter's auroras can be a variety of colours, including blues and reds. Moreover, they stretch across thousands of kilometres, making Jupiter one of the most visually stunning wonders of the universe. Imagine a cosmic painting where colours blend and swirl in a celestial ballet. Could Jupiter's auroras be related to its tumultuous atmosphere? The answer is yes. Jupiter's atmosphere is full of turbulence and complex dynamics, which also affect how these auroras are produced. Unlike auroras on Earth, which are relatively static, those on Jupiter are more dynamic and can change quickly. This phenomenon is a reflection of Jupiter's energetic nature, a planet where energy seems to flow endlessly. And here comes a fascinating question. Why are these auroras so important to scientists? The answer lies in the information they can provide about the planet's magnetic field and its atmosphere. By studying these bright lights, researchers can learn more about the interaction between the solar wind and Jupiter's magnetic field, as well as about the atmospheric processes occurring in this gas giant. It's as if the auroras were a secret code revealing Jupiter's mysteries. Imagine scientists as detectives in a cosmic case, using the auroras as clues to better understand Jupiter's history. What secrets could they uncover by analysing these lights? From the composition of its atmosphere to the way its magnetic field interacts with the Sun, each aurora can offer a new piece of the puzzle. This only heightens the excitement of space exploration. Jupiter's auroras also make us reflect on the nature of the universe. As we observe these bright lights, we can't help but wonder about life elsewhere. Are there other planets with similar auroras? What would auroras look like on worlds we have yet to explore? These questions drive us to keep looking up at the sky, seeking answers beyond our own planet. Every time images of Jupiter's auroras are captured, moments of pure and awe-inspiring beauty are being documented. Space missions like Juno have provided unprecedented data, revealing more about these fantastic light displays. With each new image, a window opens to the unknown, reminding us that the universe is full of wonders waiting to be discovered. Auroras on Jupiter are more than a visual spectacle. They are a testament to the complexity and dynamism of this gas giant. They show us that even in the most distant and alien places, there is a connection between the energy of the Sun and the atmosphere of a planet. It's a reminder that every corner of the universe has its own rhythm and its own stories to tell. So the next time you think of Jupiter, imagine not only its size and beauty, but also the dancing lights that adorn its atmosphere. Each aurora is a reminder of the vitality of this planet, a spectacle that invites us to continue exploring and learning about the cosmos. Who knows what other mysteries and wonders await us in the vast universe that surrounds us? The pursuit of knowledge and curiosity are the forces that drive us to keep looking towards the stars. How does a gas giant like Jupiter influence our solar system? In this section, we will explore the fascinating connection between Jupiter and the Sun, as well as the profound effect this colossus has on its surroundings. When we talk about Jupiter, we are not only referring to an impressive planet, but a true titan that acts as a guardian in our cosmic neighbourhood. Jupiter has a mass that exceeds more than 2.5 times that of all the other planets in the solar system combined. It's as if we have a large protector at the entrance of our stellar home. But what does this really mean? Its immense gravity not only attracts asteroids and comets towards it, preventing these rocky bodies from becoming a threat to the inner planets like Earth. In this sense, Jupiter acts as a shield, protecting us from potential catastrophic collisions. The relationship between Jupiter and the Sun is not just a matter of gravity. The distance between them also plays a crucial role. Jupiter is at an average distance of about 5 times that which separates the Earth from the Sun. This means that, although Jupiter is far away, its influence is felt throughout the planetary family. Its enormous gravitational field affects the orbits of nearby planets, and also those of the most distant ones, creating a delicate balance in the solar system. What about Jupiter's auroras? Those impressive bright lights that seem to dance at its poles are the result of the interaction between the solar wind, which is a constant flow of charged particles emitted by the Sun, and Jupiter's powerful magnetic field. This field is so strong that it can trap these electrons and protons, creating auroras that, although beautiful, are also a reminder of the constant exchange of energy that occurs between Jupiter and the Sun. Let's think of the Sun as a large bonfire and Jupiter as a huge shield that not only protects us, but also warms up from the fire it emits. As the solar wind collides with Jupiter's magnetic field, energy waves are generated that feed its auroras. This leads us to wonder. Could there be a similar effect on other celestial bodies that orbit our Sun? The answer is yes, but Jupiter, with its size and magnetic field, generates more extreme phenomena. Observing Jupiter's behavior raises intriguing questions. How does its enormous gravity affect the other planets? Jupiter not only generates its own complex atmosphere, but its presence also influences the formation and evolution of the solar system. For example, some scientists suggest that the migration of the planets, that is, how they moved in their orbits over time, could have been influenced by Jupiter's massive gravitational attraction. In addition, Jupiter's role in the creation of Earth is a fascinating topic. Its enormous gravity could have helped clear the way for Earth to form in a safer environment, by attracting potentially destructive objects towards itself. This makes Jupiter not just a distant giant, but also intrinsically related to our own history. The relationship between Jupiter and the Sun also manifests in the solar system's climate. Variations in solar activity can directly impact Jupiter, and in turn, Jupiter's huge influence can modify the way other planets interact with the solar wind. It's a cosmic dance where each participant plays a crucial role. And what about impacts? Jupiter has suffered numerous collisions throughout its history, such as the famous case of the Shoemaker-Levy 9 comet in 1994. This event was not only an impressive spectacle, but also provided valuable information on how impacts can affect a planet and, by extension, the entire solar system. Jupiter's gravity acts like a magnet, attracting these celestial bodies and allowing scientists to study the consequences of these events. The relationship between Jupiter and the Sun is a reminder that our solar system is a dynamic and constantly changing system. Every planet, every moon, and every asteroid interact in complex and surprising ways. Jupiter, with its enormous size and gravitational power, is not just a solitary giant. It is a main player in the history of our solar system. So the next time we look at the sky and think of Jupiter, let's remember that this gas giant is not only an amazing visual spectacle, but also a key factor in the stability and formation of our cosmic home. Its connection with the Sun teaches us that our existence here on Earth is part of an intricate web of cosmic relationships, where size and gravity play a fundamental role in the dance of the universe. The exploration of Jupiter and its moons has opened a fascinating chapter in our quest to understand the universe. What have we learned so far about this gas giant? First and foremost, Jupiter is not just a planet. It is a natural laboratory that provides us with clues about the formation of our solar system and, potentially, about life itself. Each discovery brings us closer to answering questions that have been on the minds of humanity since time immemorial. The immensity of Jupiter, with its stunning size and constantly moving atmosphere, reminds us of how small we are in comparison. How is it possible for such a large planet to exist, and what conditions exist within it? Every time a space mission approaches Jupiter, it offers us a new look at its composition and dynamics, revealing secrets that could change our understanding of planets in general. Jupiter's moons in particular have proven to be areas of great interest. What mysteries do Io, Europa, Ganymede and Callisto hide? Each of these moons has unique features that make them stand out. For example, Europa is known for its icy surface, which could hide an underground ocean. Could this ocean be a refuge for life forms? The answer to this question could have profound implications for our search for life beyond Earth. The Juno mission has provided valuable information about Jupiter's atmosphere, but it has also revealed how this planet interacts with its environment. Did you know that Jupiter's powerful magnetic field is the strongest of all the planets in the solar system? This field not only protects its moons, but also creates spectacular auroras at its poles. What does this mean for the habitability of its moons? The answer to this question may be key to understanding how Jupiter's environment influences its satellites. The impact of the Shoemaker-Levy 9 comet on Jupiter was an incredible event that showed us the vulnerability of planets to celestial bodies. How did this impact affect our understanding of the solar system and planetary dynamics? Each collision teaches us something new about the history of our cosmic neighborhood and about the dangers that could threaten Earth. One of the most intriguing aspects of Jupiter exploration is the search for life on Europa. If there really is an ocean beneath its surface, what kind of life could inhabit it? The exploration of this icy world could open the doors to discoveries that would forever change our understanding of life in the universe. Science advances with cautious steps, and each mission brings with it the hope of answers to questions that have intrigued scientists and dreamers alike. We cannot forget the volcanic activity of Io, the most active moon in the solar system, how can such a small celestial body generate so much energy and activity? The answer lies in the gravitational interaction with Jupiter and its other moons, which creates a dynamic and constantly changing environment. This phenomenon is not only fascinating in scientific terms, but also helps us understand how worlds form and evolve in our solar system. When thinking about the formation of Jupiter, many questions arise. How did such a massive planet form, and what role did it play in the creation of other celestial bodies? Theories about its formation allow us to better understand the history of the solar system and how the planets relate to each other. Each new discovery about Jupiter sheds light on the conditions that led to the creation of our home in the cosmos. Jupiter's chemistry is another exciting field of study. What elements and compounds are found in its atmosphere? The answer to this question is not only interesting in itself, but also has implications for astrobiology. The chemical composition of a planet can provide clues about its potential to harbour life. In this sense, Jupiter is a true enigma that continues to challenge scientists. An aspect that is often overlooked is the connection between Jupiter and the Sun. How do these two giants interact? Jupiter's gravity influences the orbit of other planets and asteroids, acting almost like a guardian of our solar system. This relationship makes us reflect on Jupiter's role in the history of our cosmic neighbourhood and how its presence has helped shape Earth. In summary, the exploration of Jupiter and its moons has provided us with a treasure trove of information about the universe. Each mission, each discovery, brings us one step closer to understanding not only Jupiter, but also our own place in the cosmos. The search for life, the study of its atmosphere, and the analysis of its moons are just some of the facets of a much larger puzzle. The importance of space exploration lies in our innate desire to discover the unknown. Jupiter, with its grandeur and mystery, is one of the last frontiers that invites us to keep exploring. What else will this gas giant reveal in the future? Human curiosity never stops, and the universe remains a vast sea of questions waiting to be answered. The exploration of Jupiter is just the beginning of an adventure that could change our view of the cosmos and of ourselves. The exploration of space has always been a reflection of the human spirit. Since time immemorial, we have looked at the starry sky and wondered if we are alone in the vast universe. In this regard, the exploration of Jupiter and its moons has opened a fascinating window into the unknown. But what have we really learned about our solar system and the possibilities of life beyond Earth? The search for life on other worlds is an ancient dream, but each mission, each discovery, brings us one step closer to answering that fundamental question. Jupiter, the gas giant, is not just a colossus in space. It is a cosmic laboratory where phenomena that challenge our understanding can be observed. Jupiter's moons, especially Europa, offer us fertile ground for the hope of finding life. What secrets does its icy surface hide? Science, in its essence, is a journey of questions and answers. As we explore more about Jupiter and its moons, new unknowns arise. For example, if Europa harbours an underground ocean, what forms of life could exist in that environment? Perhaps organisms that we have never imagined, adapted to extreme conditions. Could it be that, instead of looking for life similar to ours, we have to broaden our definition of what constitutes a living being. The connection between Jupiter and the Sun also teaches us important lessons about the dynamics of the solar system. Jupiter's gravity acts as a protective shield for Earth, attracting asteroids and comets that could otherwise collide with our planet. Is Jupiter, then, not only a gas giant, but also a guardian of the solar system? This protective role highlights the importance of understanding its nature and behavior. As space missions continue to reveal more about Jupiter, the human desire to explore and learn becomes more palpable. But why is this search so essential? The answer lies in our innate curiosity and the need to understand our place in the universe. Each discovery about Jupiter and its moons reminds us that we are not alone in this vastness, that there are other worlds, other possibilities. Reflecting on our achievements in space exploration leads us to think about the future. The next generation of scientists and explorers will have the opportunity to continue unraveling the mysteries of Jupiter. What new technologies and approaches will emerge to study this gas giant and its intriguing moons? The story of space exploration is far from over. In fact, it is just beginning. The exploration of Jupiter also raises profound philosophical questions. If we find life on Europa or another moon, how would that change our perception of life itself? The notion that life can arise in conditions different from those we know challenges our beliefs and invites us to rethink our relationship with the universe. We are at a crucial moment in human history, where our desire to know confronts the reality of the unknown. Likewise, the search for life on other planets confronts us with the fragility of our own home. Earth is a small blue dot in a vast cosmos. Each discovery about Jupiter and its moons reminds us of the importance of taking care of our planet and its biodiversity. Space exploration is not just an academic exercise. It is a call to action to preserve what we have. As we conclude this reflection, it is clear that the exploration of Jupiter is just one chapter in human history. Curiosity drives us forward, and each mission offers us a new perspective. The desire to discover if there is life beyond Earth is a thread that connects all human beings regardless of our culture or place of origin. What discoveries await us in the future? The importance of looking at the sky, questioning and exploring cannot be underestimated. Each question that arises from our exploration leads us to new questions, creating an endless cycle of discovery. This drive to understand the unknown is what makes us human, and it is a legacy we must continue. So ultimately, the exploration of Jupiter and its moons is not just about science. It's about the search for answers to the biggest questions we ask ourselves. As long as we keep looking at the stars, we will keep alive the hope that we are not alone, and that perhaps the universe has much more to reveal to us.